A very pleasant day to everyone. I am Dr.S.Kanimozhi. I am working as a professor in Department of Electronics in PhD College of Arts and Science. I am going to explain about the architecture of 8051 microcontroller. Introduction. A microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. In a typical microcontroller, it includes a processor, memory and input-output peripherals on a single chip. Some microcontrollers has von Neumann architecture which can use single memory address for either program code or data. The 8051 has a Harvard architecture which uses the same address in different memories for code and data. 8051 block diagram, arithmetic and logic unit. With the help of the ALU, we can perform all the arithmetical and logical functions. ALU directly connected with the accumulator, the A register called as accumulator. It is a 8-bit register. With the help of the accumulator, we can perform all the arithmetical and logical functions. Without accumulator, we can't perform any arithmetical and logical functions. We can store all the data automatically into the accumulator. B register is a special function, it's a general purpose register that is only used for the purpose of multiplication and division. PSW, program status word. It represents the status of the program and it includes different flags. And a program counter is a 16-bit register. The program counter it is having two parts, that is PCH and PCL. PCS means, H means program counter high, PCL means program counter low. DPTR means data pointer. It is also having two parts, that is DPH and DPL. DPH means data pointer high, DPL means data pointer low. It is also placed in external memory that is connected with 8-bit data and address buses. Special function registers include in RAM. RAM is it is having two memories, that is RAM and ROM. RAM means random access memory, ROM means read-only memory. The RAM, it has some specific function registers also available in that. Working registers and bit addressable areas and general purpose areas also include in this RAM memory. ROM memory called as program memory. 8051 microcontroller, it has 4 ports, that is port 0, port 1, port 2, port 3. Port 0 act as a IO port, it act as a address bus also. Port 1 act as a IO bus only. Port 2 act as a IO bus and also data and address bus. Port 3 perform all the control functions, that includes port 3 act as a IO port and also with the help of the port 3 we can perform, the 8051 can perform interrupt functions, counter function and serial data function, read-write function. That is also connected with the system timing, system interrupt timings and data buffers memory control. It includes EA. EA means external address, that is external access that is used to access the memory, enable and disable the memory, disable the external memory interfacing. Address, next one ALE, address latch enable. This pin, which stands for address latch enable, it is used to demultiplex the address data signal of the port. And PSEN, PSEN means program store enable, which stands for program store enable. It is used to read a signal from the external program memory. And XTAL, XL81, XL82. These two pins are used to set the crystal frequency of the 8051 microcontroller. Reset pin, which is used to reset the microcontroller to its initial values. VCC and ground, these two pins are used to set the power supply of the device. And internal RAM structure, it includes 4 different register banks are available in 8051 microcontroller. Bank 0, Bank 1, Bank 2 and Bank 3. Each and every bank, it is having different 8 general purpose registers. That is R0, R1, R2, R3, R4, R5, R6, R7 and R6 and R7. And it is also having some bit and byte addressable areas including RAM memory. And it is also having some special function registers, that is IE. IE means interrupt enable, IP interrupt enable. That means it is used to enable and disable the interrupt. And IP means interrupt priority. Interrupt priority is used to set the priority of the interrupt as high or low. And PCON. PCON means power control register. This is used to control the microcontroller power modes of the device. This is not bit addressable. And next one is S buffer. S buffer means serial data buffer. It is used to transmitting and receiving the data serially. This is only used in serial communication. Without S buffer, we can't transmitting and receiving the data from microcontroller to external device to microcontroller. And the next one is SCON. That means serial control register. It is used to control the 8051 microcontroller serial ports. And the next one is TCON. That means timer control. This is used to start and stop the bits of the timers of 8051 microcontroller. TMOD, timer mode. TMOD is used to set the operating modes of the timer 0 and timer 1. And TMOD means timer mode. This is used to set the operating modes of the timer 0 and timer 1. And TL0, TH0, these two registers are included in operating the timer 0. TL1, TH1, these two registers used to operate the timer 1. TL represents timer low, TH represents timer high. This is the block diagram informations. The next one, the features of the 8051 microcontroller. It is having 8-bit central processing unit. It is having 16-bit program counter and 16-bit data pointer, and it is also having 8-bit program status word and 8-bit stack pointer, and 4K bytes of on-chip program memory, that means ROM, 128 bytes of on-chip data random access memory RAM. Arithmetic and logic unit performing all the computing functions. Accumulator is a 8-bit register. With the help of the accumulator, before execution, the accumulator acts as a storage device. After execution, the accumulator acts as a memory. All the data will be stored to the accumulator. Arithmetic and logic operations, one of the operand is compulsory in A register. The result is always stored in the accumulator only. Carry, auxiliary carry, overflow, parity, all these registers are included in the status register. Instruction decoders and control. When an instruction is fetched, it is loaded in the instruction register. So without instruction register, we can't load the instructions. Decoder decode the instruction and establishes the sequence of the events to the follow. Instruction cycle. Instruction cycle is defined as the time required for completing the execution of an instruction. So instruction cycle mentioning the how many T states are included in a separate instruction. Instruction register is not programmable. It cannot be operated through any instruction. Control unit generate control signals necessary for communication between the processors and the peripherals. And the next one, CPU registers. CPU registers we call A register and the B register called as CPU registers. We can use address of the A register alternatively in our programs. The A register address of the A register is E0H. It is a 8-bit register that is directly connected with the arithmetical logical unit. In multiplication, one of 8-bit operand stored in A, and after operation it stores lower bytes in the accumulator. In division function, it holds the 8-bit dividend and the quotient is stored in the accumulator. B register. The address of the B register is F0H. It is also a 8-bit register. It is used with multiply and divide operations only. In multiplication, after operation, it stores higher byte in B register. In division, it holds 8-bit divider and remainder is stored in the B register. These are the 8-bit registers of 80, which this diagram shows the which kind of 8-bit registers available and 16-bit registers available in 8051 microcontroller. Stack pointer is a 8-bit register. It is with the stack pointer we can store the data at the time of the program execution temporarily into the stack pointer. Accumulator is a 8-bit register of 8051. B register is the one of the 8-bit register of the 8051. And R0, R1, R2, R3, R4, R5, R6 and R7, all these registers are used in 8-bit registers are used in all banks. DPTR, data pointer, it is a 16-bit register available in 8051 microcontroller. It is having two separate parts, that is DPH and DPL. DPH means data pointer high, DPL means data pointer low. These 16-bit registers initially we can initiate any address and data with the help of the DPTR. Program counter. It is a 16-bit register of the 8051 microcontroller. PC is used to which instruction is going to execute. PC program counter points which instruction is going to execute. Program status word. This represents the status of the program. Carry flag. Carry flag is used to only in the with the arithmetical and logical functions. Auxiliary carry only state and reset in the arithmetical BCD arithmetical functions. F0 flag 0 available to the user for general purpose. And RS1 and RS0, these two registers, RS1 means register bank selector bit 1. RS0 means register bank selector bit 0. These two registers are used to select the register bank. When the RS1 equal to 0, when the RS0 equal to 0, it select the register bank 0. The address of the register bank 0 is 00H to 07H. When the RS1 equal to 0, when the RS0 equal to 1, it select the register bank 1. The address of the register bank 1 from 08H to 0FH. When the RS1 equal to 1, when the RS0 equal to 0, it select the register bank 2. The address from the register bank 2 is from 10H to 17H. When the RS1 equal to 1, when the RS0 equal to 1, it select the register bank 3. The register address from address of the bank 3 from 18H to 1FH. And the stack pointer. The stack pointer is stored in the RAM memory. It is a 8-bit register. It contains data items on the top of the stack, incremented before data is stored and initialized to 07H. We are having separate instructions to operate the stack pointer, that is push and pop instructions. Next one, data pointer. Data pointer, it consists of two 8-bit registers. It is a 16-bit address register. It is having two parts, that is high byte, that is DPH, and low byte, that is DPL. To furnish address informations for internal and external program memory and for external data memory. And program counter. Program counter is a 16-bit register. It specifies the address of next instruction to be executed. After reset, PC will be set to 0000H. 8051 features the instruction 1 byte at a time. After increments, it increments PC by 1. The program counter is used to program counter points which instruction is going to execute. Next one, register banks include in this, that is totally 32 bytes, lowest 32 bytes. 4 banks available, each banks it is having 8 registers. RS1 and RS0, 4th bit and 3rd bit of the program status word select the bank. Each bank contains R0 to R7 registers. These registers are called working registers. RS1 equal to 0, RS0 equal to 0, the bank 0 is selected. And this is the internal RAM organization structure. This diagram shows the internal RAM organization. Working registers from the address 00 to 07 it represents, that is bank 0. The addresses from 08 to 0F that represents the bank 1. The addresses from 10 to 17 that represents the bank number 2, bank 2. And the addresses from 18 to 1F that represents the bank 3. All these 32 lower byte registers are called working registers. At the time of the program, we can access all these registers. Bit addressable area, that is the address from 20 to 2FH. In 8051 microcontroller, it is having some bit addressable areas. And also it is also having some separate bit addressable, bit handling instructions also available in 8051 microcontroller. Through that bit handling instructions, we can access this bit addressable area. And general purpose area, that is from the addresses from 30 to 7F. This is the memory capacity, that is 4K bytes of chip ROM, 128 bytes of RAM. Program memory is used to hold startup program. Data random access memory is divided into 4 parts. The first 128 bytes, that is 00H to 1FH, that represents register banks, and the address from 20H to 2FH that represents the bit addressable area of the RAM. 30H to 7FH address that represents the general purpose registers. Next 128 bytes that includes the address from 80H to FFH that represents that the all special function registers are included in that particular address. Thank you.